Hello, today's lesson is on proportional relationships and what they look like on a graph. So by the end of this lesson, you should be able to identify a proportional relationship or a non-proportional relationship by looking at a graph, and you should be able to interpret what a proportional relationship looks like on a graph. So let's start with, what does a graph of a proportional relationship look like? So if we look at this blank graph right here, this is a relationship between time in the x-axis right here, time exercising, and that's going to result in a certain number of calories burned. Well, let's think about, if you exercise for 0 minutes, how many calories are you going to burn? Our first point on the graph is going to be 0, 0, because 0 minutes exercise will result in 0 calories burned for that activity. Now, if we go to 10 and we say, well, if you exercise for 10 minutes, then you're going to burn 100 calories. And if you work out for 20 minutes, if this is proportional, so for 10 minutes, it's 100 calories. 20 minutes is going to be 200 calories. I'm going to connect this line right here. And I'm going to put an arrow because if you keep exercising, you'll keep burning calories. This is a proportional relationship. So when we say, what does the graph look like? Well, we know it's going to be a straight line. And it's going to go through the origin, or 0, 0. Through the origin, 0, 0. And that's because if you input nothing, nothing will come out. And that's why you will always hit this point 0, 0 right here if you're talking about a proportional relationship. There's a little bit more that we can gather from looking at the graph, the proportional relationship. So we've already talked about the fact that 0, 0. This means if I exercise 0 minutes, I'm going to burn 0 calories. So let's talk about this next point right here. 10 minutes and 100 calories. Well, we can find the unit ratio or the constant of proportionality. This is going up 100 and over 10 every time. That's what's going to make it a straight line. So if I'm talking about this point right here, again, finding the unit rate or the constant of proportionality is the y value divided by the x value. My y value, I got to move down here a little bit. My y value is 100. My x value is 10 minutes. So this is just like you would see it in a table or the equation. I get 10 calories per minute. And because this is proportional, if we look at this point right here, so this point, again, y divided by x, this is 200 calories per 20 minutes, or 10 calories per minute. So what we can say right here, the constant of proportionality is 10. So just to recap, that was a lot. When you're looking at a proportional relationship, it's going to be a straight line and it's going to go through the origin. If it doesn't go through the origin or it isn't a straight line, then it's not going to be a proportional relationship. You can look and dig down into what each one of these points mean. So this means 0, 0, 0 times 0 calories. This point right here means 10 minutes, you burn 100 calories. And this right here means for 20 minutes, you burn 200 calories. We could break down any of these points to find that constant of proportionality. So let's move down. So looking at these three graphs, we want to explain why each graph does or does not represent a proportional relationship. Let's start with the first one right here. Again, is it a straight line? Does it go through the origin? Yes. This is a proportional relationship. And the reason being is that it's a straight line through the origin. We can also say it has a constant unit rate. So if I'm looking right here, I can pick any point. I like to pick what I call a pretty point. It's a point that goes right through like the plus sign of the graph. So right here, I can look at this and I can say, well, this goes, the y is 1, the x is 2. So my y over x is 1 over 2. My unit rate is 1/2 for this one. Look at the next one. Is this a proportional relationship? It's a straight line, but it doesn't go through the origin. So no, does not go through 0, 0. Last but not least, let's look at the third graph. It is not a straight line. It does go through the point 0, 0, but it's not a straight line. So this is how you can identify if a relationship is proportional or not. This says draw 2 grapes. It is not supposed to say draw 2 grapes. It is supposed to say draw 2 graphs. Hopefully I'll fix that before you get to it. That pass through the point 2, 3, one that represents a proportional relationship. So we'll do this one is going to represent proportional relationship, and one that does not represent a proportional relationship. The first thing that you need to do is you need to graph the point 2, 3. So when we're just as a review, when we're talking about the point 2, 3, the first value is your x value. That's going to be your left to right value. Your second is your y, or your up and down. So I am going to start always at the origin, and I'm going to go 2 to the right because it's a positive 2, and then I'm going to go up 3 to get my point. I can't really see. It's like right here. So 2, 3. Now, for it to go through, for it to be proportional, it also needs to go through the point 0, 0, and it needs to be a straight line. It's as straight as I can make it. You are on paper, you can probably use a ruler. Okay, now this next one, it's not going to go through this point right here. I can draw anything that I want. I can draw a curved line. I can draw a straight line as long as it doesn't go through the point 0, 0. That is going to show that it's not a proportional relationship. So you could have something different than I have for right here. Let's just practice interpreting these graphs. So here's an example. Martin and Isabel go bowling. Each game costs $10. Martin has his own bowling shoes, but Isabel pays $3 to rent. Graph each scenario. Let's start with Martin. So if he plays 0 games, then his cost is going to be $0. We know that every game is $10. So 1 game is going to be $10. 2 games is $20. 3 games is $30. This is my graph of what Martin's going to pay as he bowls. The difference here is Isabel has to pay $3 to rent the shoes. So before she plays a game, at 0 games played, she's already going to have spent $3. Now when she plays 1 game, she has to pay $10 more. So this is going to go up to here. Again, right here, it's $3 for the shoes plus $10 for the game. 2 games is going to be here. Remember, it's the 2 games plus the $3. So this is what her graph is going to look like. So we've graphed each scenario. Are they both proportional? So no, Isabel's is not proportional because she doesn't go through the 0.00. So she doesn't land on that 0.00 right there. Martin's bowling costs are proportional. Because they're proportional, we can figure out what the constant of proportionality. So what is the constant of proportionality here in this graph? Well, the constant of proportionality we're going up 10 and over 1. So this is, again, y over x, or 10 over 1. The constant of proportionality here is 10. One more example. The graph here shows the number of boxes a machine packages over time. Here's the time on the x. Here's the number of boxes on the y. Is this relationship proportional? Yes, it's proportional. It's a straight line through the origin. If so, what is the constant of proportionality? The constant of proportionality. Well, what I'm going to do is I'm going to look right here at 2 and 50. So the 0.250. What this means, again, to figure out the constant of proportionality, we're going to take y and divide it by x. So right here at this point, my y value is 50. My x value is 2. 50 divided by 2 is 25. 25, and then our units are boxes per minute. Next question, how many boxes does the machine package in 4 minutes? Well, I'm going to look right here at 4 minutes. I'm going to travel up until I hit the line, and now I'm going to travel over. And it is going to package 100 boxes in 4 minutes.